That's fine. Again, it's there if you miss class, right? For me, it's a few clicks, it's not that much work, but it's there if you missed class, or as concepts get more tricky, you might want to revisit the video. All right, so today we're taking rational expressions a step further, and we're introducing the multiplication and the division of two rational expressions. Okay, so let's let's look at the learning goals. So go ahead and read them for yourself. So Naila, you're reading this part to yourself. You already did. Okay. Ooh, here's another word to add to the list. Exciting. Do you remember that? That the reciprocal, you've heard the term negative reciprocal. We are not talking about the negative reciprocal, just reciprocal. So negative reciprocal, you may have heard when you were talking about a perpendicular slope or a line that is perpendicular, it has negative reciprocal for its slope. Whereas just the reciprocal means something that is in the numerator ends up in the denominator. Okay, I'll show you more. Okay, let's recall what we remember about multiplying and dividing with fractions. So when we multiply fractions, first of all, if we can cancel something to simplify, we will do that. We'll multiply the numerators and the denominators. I like to just draw a circle to show, or an oval to say I'm multiplying those and I'm multiplying those. So multiplication of fractions is much simpler than adding, subtracting. So A times C over B times D. Okay. Now dividing, almost there. The one difference is that when we are dividing fractions, we multiply by the reciprocal of the second fraction. What do we mean by that? So before I can do any kind of operations, I take the second fraction and I flip it. Now, because I have flipped it, the division sign turns into a multiplication sign. So I have dealt with the division sign by writing the reciprocal of the second fraction. And now that it's in multiplication form, I just multiply the numerators and the denominators. So the only difference when we are dividing rational expressions or fractions for that matter is that we have to get rid of that division sign by writing the reciprocal. So let's take this concept and apply it to rational expressions. And so instead of just cross-canceling and simplifying, we'll be factoring. Okay. And as always, we are going to state those restrictions. So let's first practice multiplying or dividing rational expressions that are built of monomials. Okay. So the first thing I see is I have a division sign. Now notice I'm building, I love using, and I expect you to use vertical equal signs. Okay. So I just rewrite the first expression. Now note that I'm going to change the division to the multiplication because I'm going to write the reciprocal of this second expression. So the reciprocal, the denominator becomes the numerator becomes the denominator. Before we multiply them, let's simplify. So let's see if we can cross cancel anything. Okay, well, I can cross cancel the 2 and the 8. So I divide each by 2, and the 2 becomes a 1, and the 8 becomes a 4. I can cross cancel the 5 and the 25, right? So the 5 becomes a 1, the 25 becomes a 5. Now for variables, it's like we're saying a cubed divided by a. Okay, so we can, I need more colors. So we're going to cancel the a, and the a cubed becomes what? A squared. Good. Okay, let's look at the b. Well, there isn't a b in the numerator. Let's look at the x. Okay, there's x squared and x to the power of 4. Where's the exponent greater? In the denominator, and that means the x ends up in the denominator. So we cancel out the x squared, and what does the exponent of x become? Right. So 4 minus 2, and I keep it in the denominator. Y cubed and y, so the y cancels out, the cubed becomes a 2. And I'll break this down. I'll show you one more way to do it. And so we end up with a much simplified, so I've got a 1. Now that it's multiplying, I'm just going to write all the factors. The y squared, the 5, and the a squared. In the denominator, I have a 1. I have a b to the power of 4. I have 4. I have x squared. And so 5a squared y squared, 4 b to the power of 4 x squared. Why do you think I wrote the a's and the b first? Alphabetical order. Okay, when in doubt, write in alphabetical order. All right, now in case this was a bit too fast with the exponents or not the way you do it, let me show you yet another way. So the coefficients are fine, right? We factor the coefficients, but what I'm going to do this time is I'm going to keep all the variables in the numerator as a first step. Okay, so I have the 1. Now the x, if I keep the x in the numerator, I'm basically going 2 minus 4, right? Which would give me negative 2. For the y, I'm going 3 minus 1, which is a positive 2. Then I've got that 5. Then I've got the a. 3 minus 1 is going to be 2. And then in the denominator, I would have the b4 and 4. Okay. If what I'm doing right now doesn't jive with you and doesn't make sense, don't worry about it. So if you end up with the variable with a negative exponent, you just remember, oh, I need to bring that negative exponent into the denominator, okay? We'll still end up in the same place, except that that's not alphabetical. Okay, go ahead and write the restrictions. And you can do it as simple as what I just did, sort of making like a list of all the variables, right? All the variables at some point were in the denominator as factors. None of them can equal to 0. All right, so let's take this a step further. Sorry, do you need a few seconds? And if you're done copying, good practice is to just review review the question and make sure you understand what the steps were. All right, let's divide the next rational expression. Here we've got polynomials, not just monomials. Again, we have a division sign. So the first thing we're going to deal with is that we can start factoring. Like if you want to start factoring, go for it. I won't just yet. And I will color code this so that we can follow where everything goes. Okay, the division becomes a multiplication. I write the reciprocal. You do not have to write this. I'm just, sometimes when I write class notes, I'll make some additional notes that might be helpful. And so here we are writing the reciprocal of this expression. Okay, so step 1, make sure you see what we did there, that it makes sense. And before you start the factoring, make a plan. Look at each expression. Are there any shortcuts? Which method will I use for each one? Okay. And what do you check for first? Oh, that's so cute. Yes, you do. All right. So let's go and factor. Okay, go ahead. I want you to factor. So just regular factoring, no cross canceling yet. So that's a common factor. Plus times. So here I've got a trinomial. Okay, my two magic numbers are 5 and -4. Another trinomial. My two magic numbers are +5 and -2. And I see, ooh, x squared minus 4. Which method do I use for that? X squared minus 4. Which one is it? Difference of square. It's my favorite. I was just thinking about that. Difference of square, DOS? I don't know. I don't actually have a, it's the opposite of FLU, but there's no acronym for this that really makes sense. Sometimes I like to actually draw it like this, Liam. It's cute. It's like the difference of squares. Okay, and so as you're factoring, every time you end up with a factor that exists in the numerator and the denominator. Do you like get kind of math excited? You're like, oh my gosh, I'm probably on the right track. Yeah. Okay. So what we can start doing is cross canceling. And so I notice, sorry, I'll give you a moment. So I notice that I have an x minus 5 in the denominator and the numerator. I can cancel them out. Is there anything else? Yes, there is. I notice that there is an x minus 2 and x minus 2 in the numerator and denominator, and I can cancel them out. Is there anything else I can cancel? Nope. Okay, but that already, yes.
That x plus 4 should be an x plus 2. So
That's right. There you go, Miss Sly. It didn't feel right. That's not true. All right, and thank you. So I made a mistake, folks. The last binomial in the denominator should be x plus 2. Mistake. Ah. Okay, and so as a result, thank you, I can cancel out the x plus 2 and x plus 2. Oh, now it's going to be really beautiful. Man, we won't often be this lucky. 4x and x minus 4. And it's just begging, the question is begging to be asked. What is the question that you think I want to ask? What do you think? No. What's the mistake that someone is going to make right now? Don't make it, but talk about it. Okay, talk with your partner. What's the mistake that will be made right now? Oh, do you want? Can you take your bags, or you're gonna be okay to get downstairs? Okay. Yeah. All right. Who's gonna tell me for 1 million points?
1 million.
Yeah. Okay, Astrid.
Someone would try to cancel out the 4s.
I think Astrid just won the point war because I've never given 1 million points. That's correct. So watch this. Someone is going to try to cancel out the 4s. It's just so tempting. Why can I? Oh, Astrid, to like fulfill your 1 million points, tell me why you can't.
That's the -4. It's not multiplying, it's subtracting.
Beautiful. So the operator in the denominator is not a multiplier. Okay, because these are not factors, it's x minus 4, not x times 4. We cannot cancel the 4th. Okay, and then Liam, you get -1 points for suggesting that we need to find restrictions because we do. Beautiful.
It's -1.
I know, isn't that exciting?
Oh my god, you're lower than everyone else.
Wow, congratulations. All right, you're not the first to get negative points. You're just the first to get negative points for a correct answer. All right. Let's go ahead. List the restrictions. Don't tell me. Write them down. Yeah, write them down. For the entire question. All right, did I miss anything? Which one? Oh, yeah. So folks, yeah, it's actually kind of hard to see. Watch here. Folks, notice that I'm using the plus or minus symbol. Efficiency. Okay, so watch here. I'm saying x cannot be equal to -5, 4, positive or negative 2. So there are 4 restrictions. I used to say that I want them in order. It's fine. Just list them. Now, here's a question, Kajik. How many people did restrictions for the light green expression? Oh, no one did? Folks, was the light green expression ever in the denominator? Yaha. It used to be here, right? So do you have to restrict it? Yes. Because at some point in its lifetime, it was in the denominator, right? So even though we took the reciprocal, what that means is you actually have to restrict both numerator and denominator when you are dividing rational expressions. Make sense? So it turned out that you were fine because the light green one had a -5 similar to here and a +2 similar to here. But if that weren't the case, you wouldn't be fully restricting the expression because the entire, like both of these have to be restricted. Make sense? You want to make a note for yourself? Yeah. Great question. No, because it's always in the numerator, right? This 4x is in the numerator. And you can have a fraction that is 0/2. That's just 0. That's fine, right? So you can have a 0 in the numerator. Okay, so my note was restrict both numerator and denominator when dividing. All right. Okay, here's a fun one. I wish it were Friday afternoon. Like, this would be a true gift. All right, is it horrible? No, it's just many, many parts. Okay, so before we start this, take 30 seconds to look at this question and decide what will be the plan of attack. All right, so first thing first is we need to write the reciprocal. I'm going to start factoring. No, I won't start factoring. Okay, I'm going to write it in my color codes. And then so how do I write the reciprocal of 3x plus 2? Well, the 3x plus 2 goes in the denominator, and the numerator is just a 1. Okay? We're good? Okay, next. So for this trinomial, it's a simple trinomial. So let's factor it. So I've got 9 times 5. X plus 9, x minus 5. Denominator. So it's got to add up to -10, multiply to +9. That sounds like a -9 and a -1. So you see how quickly we're factoring. Did I?
Wouldn't it be a positive times negative? Because -9.
Oh, because they have to add. Yeah. Is it? Wait. They multiply to give you. Sorry, this is a multiplication. So they multiply to give you +9. -9 times -1 is positive. Yeah. Okay. We'll do this bottom one because I see the top one's asking for some decomposition. I don't like that. Okay, so here, x plus 9, x minus 1. So you see how quickly we're factoring, right? Obviously, if you want to take more space, more time, that's cool. But just a realization how strong your factoring has to be. And then for this decomposition, I will do some work on the side. So I've got 6x squared minus 5x minus 6. And I know that the two magic numbers have to add up to -5 and have to multiply. So they have to add up to be -5, and they multiply to give me -36. Well, isn't that fun? And I'm thinking 9 times 4. Yeah, Miss Sly, that sounds about right. 9 times 4. And which one is negative? What's the 9? All right, so let's decompose. Minus 9x plus 4x. I know I'm going a bit fast. I just see that I've got 6 minutes. We'll get there. And so I group by factoring. And I group by factoring. And it feels about right. 2x minus 3 and 3x plus 2. All that work for one trinomial. 2x minus 3, 3x plus 2. And now I look at cross-canceling. So I can cancel the x plus 9. I can cancel the 3x plus 2. Anything else? No. Can I cancel the x minus 1s? No. They're both in the denominator. Okay. And so I end up with x minus 5 times 2x minus 3, x minus 9, x minus 1 all squared. That's it. Notice that I squared the x minus 1 just for efficiency. And then for restrictions, I might have a list. I'm going to have positive negative 9, positive 1, and then for the 3x plus 2, I say it can't equal to 0. So you bring the 2 over. 3x cannot be equal to -2. Divide by 3. Okay, so x cannot be equal to -2 over 3. And I add that, -2 over 3. So when you're doing your homework, make sure you try those harder questions, right? If that means doing every second question, cool. Just make sure you get to those difficult questions. We will be covering this topic again tomorrow. And then, folks, the quiz that we have on Wednesday is basically the first 3 lessons, including this lesson.
Is this the last lesson?
That's correct. Tomorrow we do a little more of this lesson, we review, and then the quiz on Wednesday. All right, folks, well done.